Let us continue from HCN. The carbonyl compounds reacting with HCN, that reaction we'll see. Now, carbonyl compounds reacting with HCN in the presence of what? In the sense, in the presence of base. Carbonyl compounds reacting with HCN in the presence of base. Okay. What is the necessity of this base? What is the necessity of this base in the sense? HCN we are taking, this OH minus we are taking, OH minus. This OH minus is taking H plus and making the HCN as Cn minus. Cn minus. This Cn minus can attack this carbonyl carbon and proceeds nucleophilic addition. If you do not add OH minus, what will happen means only HCN will be there. This HCN is a weak acid, it undergoes partial ionization to give Cn minus. This concentration is low, therefore nucleophilic addition reaction will be low. Here in the sense nucleophilic addition reaction will be high, because cyanide concentration is more here. Therefore HCN addition with carbonyl compound is catalyzed by what? In the sense base. Okay, so carbonyl compounds undergoes nucleophilic addition reaction. One reaction we have seen with the HCN we have seen. Next reaction we will see with the NaHSO3. Now we will see carbonyl compound. Carbonyl compound will take with NaHSO3 will take NaHSO3. NaHSO3. So what is the reaction we'll see? So carbonyl compound will take this carbonyl compound. Here in the NaHSO3, what will attack? What will attack? That we will see. This S, this O minus, double bond O, OH, lone pair, and Na plus. It is called NaHSO3. NaHSO3 we can write like this. NaHSO3 we can write like this. Okay. Now, how it is attacking the carbonyl compound, that we'll see. How it is attacking the carbonyl compound. One possibility, this O minus can attack this carbon, therefore this pi bond will shift. So that we are getting here O, S double bond O, OH. Then here O minus will be there. This pi bond is shifting, so it is O minus, Na plus comes here. Na plus comes to this place. Next step what happens means, this H plus goes to this place, Na plus comes to this place. Next step is this H, this bond is shifting here, therefore O minus, this is H plus going here, Na plus coming here. So you will get it is OH, it is what? In the sense O, S double bond O, O minus, Na plus. Sulfur will have one lone pair. Okay. So this carbonyl compound, in this carbonyl compound, this carbon is added with this O, SO, this O, SO, O minus. This H plus, this H plus is converting this O into OH. Okay, sodium bisulfite in the sense like this reaction possible. Okay, now we will take acetaldehyde. Now we will take acetaldehyde. We will take this acetaldehyde will treat with the NaHSO3. NaHSO3, what we will get, we will see. This CH3 will write C, double bond will make it a single bond O, double bond O will make it a single bond O. This we will make it as, this O we will make it as OH. Here what we will do in the sense O, SO, O minus, Na plus. Okay, like this we will write. This is called what? In the sense acetaldehyde, sodium bisulfite, acetaldehyde, sodium bisulfite we can say. Now we will take acetone. With the sodium bisulfite we will take NaHSO3 will take. So what we will get in the sense CH3, C double bond O will make it as single bond O. This O we will make it as OH. Here O, S double bond O, O minus, Na plus. This is called what? In the sense acetone. This is called acetone, sodium acetone sodium bisulfite. Acetone sodium bisulfite we can say. This is called acetone sodium bisulfite. Okay. Now this bisulfite on hydrolysis gives what? That we will see. This bisulfite on hydrolysis gives what? This on hydrolysis in the presence of acid. This on hydrolysis in the presence of acid, what we will get? That point we will see. This bond is breaking here, H plus and OH minus. Okay. So this is becoming what in the sense NaHSO3. Sodium bisulfite, what we have taken initially, that is coming out. So this is what becoming what means CH3, CH, OH, OH. Okay. So how the bond shift will be there in the sense from here water will be removed. So what you are getting means acetaldehyde you are getting. Okay. So this on acidic hydrolysis you are getting back acetaldehyde. So basic hydrolysis means what will happen? Basic hydrolysis means what we will get, that we will see. Base will take OH minus. Okay. Base in the sense we are taking OH minus. So here OH we are taking. Base in the sense OH minus we will take. Here oxygen is having 3 lone pairs. Okay. Now we will take this OH minus is abstracting this proton. Therefore, water will be removed. This bond will shift here. Okay. We have removed water. So what we got in the sense CH3, CO minus. This O minus oxygen is having 3 lone pairs. This CH3, O, S double bond O, O minus Na plus. Next step what in the sense this lone pair comes as pi bond. This bond is shifting here. Therefore, we will get this is becoming what in the sense acetone. That is becoming acetone. What is this in the sense O minus S double bond O, O minus Na plus. Okay, this is removed. So we got back acetone. So that this NaHSO3 on treating with a carbonyl compound we are getting sodium bisulfite. This on acidic hydrolysis giving back carbonyl compound or basic hydrolysis giving back carbonyl compound we can say. So what is the use of this? What is the use of this in the sense suppose if you want to separate carbonyl compounds from other compounds, then we can use this method. Okay. So carbonyl compounds react with the sodium bisulfite to give like this addition compound we are getting. This addition compound on hydrolysis in the presence of acid or base giving back carbonyl compounds. Sir. Then carbonyl compounds react with the Grignard reagent. Then reaction of carbonyl compounds with alcohol we will see. Now we will take carbonyl compound, for example, acetaldehyde we will take. This we will treat with what in the sense alcohol. This we will treat with alcohol in the presence of what in the sense dry HCl. In the presence of dry HCl, what we are getting in the sense acetal. We are getting acetal. This acetal again on treating with alcohol. This acetal again on treating with alcohol in the presence of dry HCl gives what in the sense acetal. Gives acetal. Okay, gives acetal. Now we will see the mechanism for this. We will see mechanism for this one. Now we will take the mechanism. This aldehyde will take. This aldehyde we are taking. This oxygen is having 2 lone pairs. From HCl, H plus is attacking. From HCl, H plus is attacking this O. So we will get a oxygen positive charge we are getting, like this we are getting. Next, alcohol comes for attack. Next, alcohol comes for attack. This oxygen is attacking this carbon. This pi bond is shifting to this oxygen. So we are getting a here OH. This oxygen is having 2 lone pairs. Here this alcoholic oxygen is added. Therefore, this oxygen is having positive charge. Okay. Next step we will see. Next step what in the sense This H plus, this bond is shifting to O, H plus is leaving. So we are getting RCH, this OH. Here what we are getting means this O, this R dash. We got like this. Here this carbon is having one alcoholic group and one ether group. Therefore, this is called acetal. So acetal in the sense carbon will have one alcoholic group and one ether group. This carbon is having one alcoholic group, one ether group. Therefore, this is called what in the sense acetal we can say. Next step, H plus. H plus is attacking this acetal. This lone pair is attacking this H plus. Therefore, we are getting RCH. Here OR dash. This oxygen is having two lone pairs. This is OH. Another H is coming. It is having positive charge. Okay, like this we are getting. Next, we will treat this with alcohol. Next, we will treat this with this is attacked by alcohol. Therefore, this oxygen is attacking this carbon. This bond is shifting. So water is leaving. Water is leaving. So what we are getting in the sense RCH OR dash. This oxygen is having two lone pairs. Here alcohol is attacking. Alcohol is making a bond. This is having positive charge. Next step we will see. This bond is shifting to oxygen as a lone pair. So H plus is leaving. So what we are getting in the sense RCH, this OR dash. This oxygen is having two lone pairs. Here what is there means OR dash. This oxygen is having two lone pairs. Now this carbon is having two ether groups. This carbon is having two ether groups. Therefore it is called acetal. So acetal in the sense carbon will have two ether groups. acetal in the sense carbon will have one OH group and one ether group. One OH group and one ether group. That is called acetal. Okay. Now we'll take this all here. This aldehyde reacting with 2 times alcohol. Here 1 time alcohol. Here 1 time alcohol. Here 1 time alcohol. 2 times alcohol. So instead of 2 alcohols, let us take diol. Let us take diol. What is the compound we will get? That we will see. On taking diol, what is the compound we will get? That point we will see. Okay. So now we will take aldehyde. We are taking what in the sense diol we will take. Okay. We are taking diol. If it diol we are taking and dry HCl gas we are taking. So what we will get? That we will see. This R, this H. Here this carbon is this carbon. This carbon is having R and H that we have written. This carbon is making bonds with the oxygens like this. This is what in the sense this is called cyclic acetal we can say. Cyclic acetal. That means this carbon is having two ether groups. This carbon is having two ether groups. It is having. This carbon is having two ether groups. Therefore, it is called a cyclic acetal. Suppose if we take ketone. Suppose we are taking ketone. This is diol, dry HCl gas. What we will get in the sense? Okay. These two R groups we have written. Then we will write like this. Okay. It is called what in the sense? Cyclic ketone. This is called cyclic ketone. Okay. Now, this acetal on hydrolysis in the presence of acid gives back carbonyl compounds. This acetal on hydrolysis in the presence of acid. Acetal on hydrolysis in the presence of acid, what happens means gives back carbonyl compound. Gives back carbonyl compound. Gives back carbonyl compound and alcohol. Alcohol also will be formed. Alcohol also will be formed. Sorry. So acetal on hydrolysis in the presence of acid, what it is giving back in the sense carbonyl compound and alcohol it is giving. Sorry. That means where we can use this reaction, where we can use this process. Suppose if you want to protect carbonyl compound in a reaction, then what we have to do means